Does economics have anything to say about voting? The answer is yes. Economic thinking applies to all sorts of political issues, beyond the obvious things like, is policy X efficient? In the case of voting, the two big questions to ask are, what is the expected value of a vote on the margin, and what is the marginal cost of a vote? So we're going to consider a thought experiment. In this example, we've got three candidates running for office, A, B, and C. A has policies like, let's think about economics. Let's run cost-benefit analyses to see if programs are worth keeping around and to decide what we're going to spend our money on. Candidate B says, let's stick with the status quo. We're not going to change anything. And candidate C says, let's do things like kicking puppies and shaking babies. So if A wins, it's like our region gets richer by $1 billion, right? So A, it's definitely better than B because we're getting $1 billion between us. With C, we're getting 0 extra dollars. And with C, well, they're even worse. There, it's like we're losing $1 billion. So A is greater than B is greater than C. So it should be straightforward. We vote for A. But here's the catch. A is a third-party candidate. So A isn't one of those parties that has a little R or a little D or a little red or blue sign. A is some candidate that isn't likely to win. Now, received wisdom here tells us a vote for A is a wasted vote. Now, we're going to see just how wrong that viewpoint is. And in fact, that viewpoint, I would say, is even worse. Well, I don't know. Is it worse than candidate C? It's a bad view. Now, this is me making a normative claim here, but I'm going to say the view that a vote for A is a wasted vote is almost certainly going to be a morally ugly view. I'm going to say it's cynical. I'm going to say it's ugly, and I'm going to say it's not a good thing. Now, let's build up to that. That's a normative claim, but I'm going to back it up with some positive analysis here. So, to understand what the logic is behind this, we need to think about how much your vote is worth. And to understand that, we want to introduce a new concept. It's a simple concept. It's the idea of expected value. Now, we should also think about the fact that voting is not the only way to uphold your civic duty. So in this year's election, it's likely that voting is going to take 2 or 3 or maybe 4, maybe even more hours of your life. And we might ask, what else could you do with those 4 hours? How does your vote compare to the possibility of, say, spending those hours writing letters to Congress, or even earning money and donating the money to causes? There are a lot of perfectly legitimate ways to fulfill your civic duty, and asking how good is voting compared to those, well, the idea of expected value is going to be really helpful here. Now, the concept is really just to say, let's look at a weighted average where we're weighting our outcomes based on the probability of those outcomes. So I'm introducing a little bit of mathy looking stuff here, but all this means is we're looking at the probability of some event X. We're going to ask about the value of X. We're going to say the probability X doesn't happen, and then the value of X not happening. Right? So probability of X, and then the value of X, and then the value of not X. In this case, we're going to think about the probability A wins, the probability B wins, the probability C wins, and then the value of each one. Now, specifically, we need to think on the margin. We need to think not just what is the probability that they win, but we need to think about the probability that your vote changes what happens. Now, really quick, before we get further into that, let's just use a really simple probability idea to wrap our heads around expected value. So let's say we've got a game where we flip a coin, and if that coin comes up heads, hey, it did, you get $1. If it comes up tails, which, hey, it did, you lose $1. So in that world, we can think of our two basic outcomes. One is you gain $1, one is you lose $1. Then we can think, what are the probabilities that that happens? We have a 50% chance that you gain, we have a 50% chance that you lose, and given this setup, our expected value equals 0.5 times 1 plus 0.5 times minus 1, which equals 0. If you play this game many, many times over, you expect on average to break even. If you play 1,000,000 times, you're going to win about 500,000 times, and you're going to lose the rest of the time. Your best guess at where you will be after playing this game 1,000,000 rounds is that you'll be right back where you started. You will have gained about $0. Now, you might get lucky and end up higher, you might end up unlucky, end up lower, but you expect to be close to where you started. So how does this apply to the question of voting? Well, now we need to think about how the outcome might change, how the election might turn out, ignoring your vote, and then ask how your vote is going to change that. Now, like I said, B and C are two big party candidates. You can make B whichever of the two parties you like better. Doesn't really matter. We're just going to say it's one of these two that are going to win. Now, how might that turn out? It might turn out that B wins by, let's say, 100,000 votes. Right? That's one possibility. Another possibility is C wins by something like 100,000 votes. And we'll throw in another possibility, which is an exact tie. So we'll call these scenarios C. Now, we shouldn't use C because let's call it X. We'll call it X, Y, and Z. So under these different scenarios, if we are in situation X, that's where things are interesting. So let's start really quickly with the easier ones, Y, which is blue, which is C wins, and Z in red, where B wins. Right? They win by 100,000. So, given that possible outcome, what happens if you vote for B? Well, the outcome is B wins. What about if you vote for C? Well, again, B wins. And if you vote for A, again, B wins. B wins no matter how you vote if candidate B ends up winning the election by really more than one vote. Right? You only get to cast one, so even if this is not 100,000, it's just, well, if it's exactly one, in that case, you can turn it into a tie. But that's not the only possibility, and it's not a very likely possibility. Right? So with situation Y, we have the same sort of a scenario, but C wins no matter what you do. It's only in situation X where your vote chooses B or C. So if you expect to be in scenario X, that is the situation where a vote for A is potentially a wasted vote. Let's say we had a really funny set of rules where if there's an exact tie, we flip a coin. Then we can think about what is the expected value of outcome X. And if it's going to be randomly B or C, our expected value is 0.5 times 0 plus 0.5 times minus $1 billion. So we expect society to be poorer by $500 million. Now, another aspect of this we need to think about is, well, that's society as a whole, but how much of that do you get? Now, let's say you are unemployed and you got nothing going on and nothing's likely to change. Let's say you're a buggy whip maker. You have obsolete skills and you're not updating them. You were out of date 50 years ago. It doesn't matter to you with B or C wins. These losses fall on other people. So in that situation, it doesn't matter to you whether or not B or C wins. But let's say you are in a situation where you would suffer some of those losses. We would say the expected impact to you of allowing it to come to this situation is this loss times your share of it, right? So this is the societal wide level expected value, and your value might be something like that society-wide level of 500 million. And let's say you are one out of, let's say this is for Suffolk County. There's about 1 million people here. So you get 1/1,000,000th of that outcome, which means you lose about $500. Well, that would be quite a bit. $500 gives you a pretty strong incentive to worry about that possibility. But if we're in scenario Y or scenario Z, it doesn't matter what you do because the outcome is decided without you. So this is the bad news about voting. Your vote doesn't matter on the margin. As a rule of thumb, if we're dealing with an election of more than 5,000 voters, the chance that we end up with that tie is effectively zero. So if we're talking about who's going to be class president, your vote absolutely matters on the margin. But if we're talking about who's going to be president, even in a swing state, your vote is astronomically unlikely to break that tie. Now, here's the flip side of that. And we kind of pointed at this when we thought about what's the possibility that maybe your share of this cost is zero, right? And if that's the case, it doesn't matter if you vote for B or C, it effectively becomes free. So the fact that your vote doesn't matter means really your vote is free, which means you can vote for A. You don't have to vote for the lesser of two evils. And this is the good news. Your vote matters on average. So what happens when you do vote for A? Well, A doesn't win, but next election, candidate B says, let's be a little bit more like B. Candidate C says, let's be a little bit less awful. You push the rules of the competition in favor of these sensible outcomes. So that's how economics is applying to the question of voting, and that's why you should vote with your conscience. Your vote is effectively a free way for you to send a signal to potential candidates about how you want them to behave. B or C, they're going to win, but you don't have to vote for the lesser of two evils, and in fact, that is probably an evil act.